Okay, okay, we're gonna do this problem again today. Yep. Problem 4 from the weekly contest that I didn't get. Probably look at a couple different solutions and then go back to the code forces problem I was working on yesterday. Okay, we're gonna do this problem again today. Yep. Problem 4 forget. Probably look at a couple different solutions and then go back to the code forces problem I was working on yesterday. Simple technique. Here, let me show you. Reset. So what was this? What was the technique behind this one? And then looks left. Hey, what's up, Convex? How you doing? Max step left, max right. Oh, let me head P there. So in this case, it would be 3, 2. Three, 1. It's just, no, that'd be 0, 0. One, 1. 0, 0, 0, 0. And on the left-hand side, and to get any particular value, you're eliminating a whole rest of the subtree. Okay. DFS of node. UB equals dfs child. Oh, if node dot left ret of, if there is a node dot left, AB equals DFS of node dot left. If max one. Okay, if node dot. D of node dot val is ret. No, return ret. Passive root. Okay. Okay, ret equals 0, 0. Okay, so the current. The maximum we've seen so far. Okay. And pass, and then run dfs2 on root dot left. The max you've seen so far is d root dot val 1. Root dot right. Equals mx, and then d of node.val1. That's the biggest depth you're getting rid of. Max MX okay, 4 0 0 for 2. That's 1 1. Plus 2 plus max you've seen so far in any of them. And it's the max you've seen in the other half. And what step you're on in terms of what's in the other half. You know that's in the other half. This one. Ah, well, there we go. There we go. Cool, just chopping off different subtrees. Neat. Okay. 2458. So I'll throw that both in the contest and 458. 458 up high. Okay, height of the binary tree. Okay, so that is done. Well, let's take a look at other people's solutions to it. Level plus depth. Hey, what's up, Goku? So right now I'm reading through all the different ways to do that problem number 4 from the contest. It seems like there are a number of different approaches here. Probably worth my time to look at them. Yeah, the flattening thing. All right, hey, I actually lost the link. Can you give me the link to yours, Samarth? Yeah, because that. Okay, great, thank you. Um, paste bin there. Okay, great. It's saved in my text editor now. Great. Okay. Yeah, so I'm just going over a few different like approaches to this problem. Okay, so you have a timer and what I'm going to do is try and implement it in Python. I'll have it side by side, so I have like kind of a template ready. Um, okay. So. You have a timer, TNT out depth. Oh, okay, cool, you can do that. Neat. Hmm. N equals SC of the root. I'm gonna switch to the old editor. Just because I can't get rid of, yeah. Can't get rid of the stupid auto formatting. Like, it's literally, yeah, cannot stand it. Um, um, N equals none. And then TNT out depth. Okay. Def SC of node. Not node. Turn 0. Or 1 plus, on the left plus SC. Okay. On the right. Okay, so you do a single DFS to find the size of the binary search tree? Yes, why, yes it is. Antidotus, there's the problem. The problem involves a binary tree. So, regardless of whether or not the solution is in fact a segment tree, the original problem itself, yep, you have a binary tree. And this was on yesterday's weekly contest. DFS tree node root in D equals 0. Why is this parameter less? Okay. Not node, return. So, Oh no, I'm just kind of talking to myself. I'm not really. It's not really a criticism. Per se. I mean, it's perfectly logical. I mean, you can have that in. I'm just sort of asking myself why that is done and see exactly where it is called on without a parameter. But no, that's perfectly fine code. In fruits.val tune.val. DFS. So this whole timer thing, yeah, for subtrees and stuff like that. I noticed the timer thing was used for, like, I think it was the Tarjan bridge finder algorithm. Yeah, if you find a node whose child is completely encapsulated, that edge is a bridge. Like, the child's T-in is greater than the parent's T-in. The child's T-out is, yeah. For the Tarjan bridge finder algorithm. But this is actually the first time I've seen that technique used outside of when you do a DFS order of nodes. You can represent it on a continuous range. Right. I see what you're doing as far as the flattening. Once you have it flattened out, and it's kind of ordered in a sense, you can chunk out ranges to get maximums if you delete an entire range. Yeah, I mean that's fair. That's fair. Let me just read through in the code. Yeah, smart coder, the Q4. Yep. It's the Q4. Clean solution. I'm actually looking at his right now. It's right there. That is it. But actually, no, smart coder. The solution I just submitted, I believe is pretty clean. There's that. The one for this one right here. Here you go. This one was I was trying to reconstruct from memory approximately what I don't know if you were there for the contest explanation, but the first person who put in like their Python solution had a sort of thing where they memoized the max depth on the left subtree and right subtree for every node, and then as you're going down the nodes, you're chopping out whole chunks of that, which are now memoized. Yeah, but yeah. This is what it ends up being. Oh, I print D. Why do I print D? That's not good. That'll probably save a little bit of time, wouldn't it? Oh, it did not? It actually took more time? Why? I don't fucking know. Yeah, no, but did you see what happened after the print, right? This is before the print, this is after, this is before removing the print, this is after removing the print. Removing the print doubled the execution time. So clearly I like RNG rolled pretty bad. What the fuck? Okay. Well, Never mind. I don't really care. Okay, so removing the print, sped it up by 20%. Okay. Just over, like, a sample size of 4. No, this AC was from, like, 10 minutes ago, Smart Coder. Fibonacci problem? Yeah. You could try ON squared pairs for the first two numbers and form the sequence just as slowly as you can, because Fibonacci grows very fast. Only has so many terms true. Straight out of shape. Thank you for the follow. Fresh and rested. I'm relatively well rested today. Yesterday I don't know where my sleep schedule was. I had 4 hours in the morning, and then just, like, took weird naps throughout the day. It just was not working out. Oh. Okay. So what I'm trying to do right now is kind of transcribing some art solution by flattening the binary tree into an array, and then seeing what he does around that. Yeah. Yeah, times are so random. Sometimes 22 ms, again 0 ms. Yeah. Yeah, they're pretty random. Contest is usually fair about that stuff, though. I don't know. Root.left. Node look left. Okay. Yeah, okay. That's the timer method there. Tree queries. Timer equals 0, n equals size root. Oh, so you do all this outside. Also another version where you insert each node twice, once when you enter and once where you exit. You dotout node equals timer plus plus. Why would you insert each node twice? Yeah, I've only ever seen the one where you increment the timer once. Oh, wait. No, I think I have seen exit marking. I remember. Anyway. timer equals 0. Self the DFS of root and the initial depth 0. Twice as useful for pathless stuff because you can do Mohs algo in the flattened array. Cancel its contribution. Length and Q queries. Offline algorithms, okay. H and O of F time. Okay, solve the deepest root. It's just a convenience. You can replace your own implementation. Might not be. Right, exactly. And this will be the first time I've gone through it, right? So I mean, in order for me to get through it a lot of times, I have to go through it at least once, right? So that's exactly why I'm doing it here. I'll just get some reps on it. Eventually, I'll understand it. It'll take a while. Oh, you got it from that? It's a good diagram. Oh, okay. Like this thing I imagine, right? Yeah. Then yeah, I'm gonna copy this over. Maybe not read it right now, but okay. Hmm. We get def get r. Let's go 0. Yeah, the weekly was no good. No good. I did not get the fourth problem. So right now I'm trying like a number of different approaches toward it. Right now I'm translating a Samart's solution, which involves like flattening a tree and then, yeah. Yeah, it was a really good problem though. Yeah, I'll give you that. The Q4 was really nice. Um, return ants, and then this was yours. Oh no, I already have like a super clean one, in which left right equals DFS return H map. Yeah. Okay. So yeah. Yeah. This was the way it ended up being, and then for Q and queries, insert append. Oh, so you actually evaluate each of the queries specifically. Okay. Oh, interesting. So a height here equals okay. Never mind, this is a little different. You have the left right root at left current plus 1. H map root.val equals current. DFS on the root, max height equals max C plus H. For CH and H map with values. Sort of dependent max height -1. So you're separating out the nodes by height? -1, yeah, because you're counting nodes on edges. Yeah, that much I get. Yeah. Yeah. And so it's the current. Oh, so the current is the level. Okay. Okay, if the level plus the height up here. Current and the height over here. If it's less than max height, that's trivial case. It doesn't blow away anything. Otherwise, it is equal to max height. It's the only thing at this current level. Then append cur -1. Otherwise, append. Oh, take the second biggest sibling. Of. Why would you never take height list of cur -1? Right? So over here, it's like you were taking the second biggest height list from the current level siblings. Why would you never take the biggest one? Oh, because it would fall under this? Wait, -1 is the one? How do you know that that's the case, though? How do you know that the -1 is the one that was eliminated by the query? That's the thing I don't get. Right, HMAP of Q, you have a current level, and you have a certain height off of that level. Might not be the biggest height, because it must equal max height. Oh, if H plus cur is max height. Okay, if you are the biggest, right. Okay, so if right, because if it weren't the if it were the biggest, it would in fact fall under this case. Yeah. Okay. Cool. Great. That makes sense. Okay. I get the idea. Yeah. And you maintain a sorted list of like all of the top ones. Yeah. Okay. Cool. I like it. I think this was similar to like the solution that was it similar to there was another solution I was looking at that I think had the same idea. It had diagrams and everything. I never saw the code though. But here, yeah, the cleanest one I've found so far, I mean, I adapted it off someone's strategy, and I think I shrunk some of this stuff into DFS. Yeah, here, this one, you like pre-calculate like heights from the top going left, from the top going right, and you stick that in this map D. So it maps a node.val to maximum height if you're only considering the left subtree, maximum height if you're only considering the right. And then, yeah, and then what you do is you pre-calculate it for all possible nodes. You end up pre-calculating for all possible nodes and then ansx for x inquiries. So the answer is going to be this. And this DFS2 is going to be, step is going to be like what level you're at. MX is going to be like, you know, as you're going down the subtree to get to a particular node, you're cutting off whole other subtrees, and so that's where this comes in. Like, so if you're cutting off the right subtree, then use the right value. If you're cutting off the left, use the left value. And then as you're going down, yeah. Here, Telkos, I could give you this one if yeah, okay, well you get the idea, yeah. Okay. It's also in the GitHub. But anyway. Trick queries. Okay. Radix in this range. For okay, right equals max gets 1 thrill, gets 1 thrill, gets R Earth run. Oh, is this open interval? Okay. Okay. Update TIN depth index integers. Oh. Work in Python. This has to be double slash because single slash will treat it as though it's a float. Yep. R minus equals 1. Okay, technically runs. Okay, I'm gonna do like one last kind of in-depth, like try and understand a little bit more about how this solution works. But I'll be right back. 1 sec. Okay, so you have a timer, TNT out. Okay, you have tree. Hey, what's up, Artikill? How you doing? Yep. Yep. No, yesterday I was just tired as fuck. I couldn't like think at all. I'm still not entirely sure I would have solved the fourth problem if I had been like full strength. Because it was actually a really interesting and somewhat challenging problem. And I went down the wrong path of like coming up with like log n queries. Yeah, oh, your CF place was better. That doesn't happen very often, does it? Hey, what's up, Code Monkey? How'd you do yesterday? Horrendous. Like, actually, probably the worst rating I've ever gotten. My LC was about, like, 3,000 something. But it's good. I would prefer to do this, and I would prefer to get a bad rating and have an interesting problem to look at, than have a good rating and have all 4 problems be a cakewalk. What happened? This problem happened. Here, let me give you the problem. The evening contest... Oh, RDKL, the evening contest was very good. This was the best problem on it. Very good problem. And you don't need, like, a segment tree or anything to solve it. There are easier ways of doing... Yeah. But I would strongly prefer that they have problems that are this difficult on a regular basis, for the 4th problem. This is how it used to be. This is how the lead code contest used to be. And, I'm happy with it. I'm happy with this kind of format. Okay. So what do I not understand? I understand depth at no.val. Okay, so you know how... Okay, so depth is just levels. Depth is levels. Okay, you find size of... Okay, you find the size of the thing with the DFS easy. Fine. Update, get... Yeah, it's... No, I mean, I think they just have a weak problem writer who's writing. Usually. And then whoever wrote this one is very good. DFS of root 0. Cap n equals n plus 1. Position plus equals n. Violet is greater than 1. Tree of position equals value. Okay, so you put it firmly in the middle. No. 3 plus... So is this like, is this similar to like construction of Fenwick tree? The Fenwick tree operating, update method? Maybe. Maybe this, maximum tree. Oh, but that doesn't use the, TNT out. That's what I wanted to... Updated TN... Oh, so you don't need a T out per se, right? No, you do. Get R through N. This is a bit much. I can't... I'm gonna have a hard time stepping through and understanding the implementation. I'm gonna set this aside for now. But thank you for sharing. At least I was able to transcribe it to Python and then have it work. You just store tree by levels. You don't need to update the tree. Yeah, you don't need to update the tree. Okay, here, let me show you RDKL. It's in the GitHub, the clean solution in Python. It's very short, but I wanted to look at an alternative solution that Samarth in chat had, which seemed very interesting. Okay, I'm done looking at those solutions. Now I'm going to go on to multicolored segments. Add the column. Here. No, I get the explanation. I just wanted to step... I get the general idea. Okay. Right. It's just the bit manipulation and then figuring out how to traverse through. That's probably all templated stuff that you've done in the past, or like you've taken off of that article you linked. But I wanted to step through that. But I do get the general idea of what you're doing, right? Not this. It's, yeah. You have the L and the R. Okay, yeah. Okay, so you sent me this. I 2I plus 1. L. No. No. Oh, what program do you use to draw this stuff? Like Microsoft Whiteboard or something? Yeah, well, yeah, L1 is just the right child, correct. Oh, Microsoft Whiteboard, yeah, okay. Cool. Okay, fine. I'll look at it again. LN1 just checks if it's the right child, so get L through R. As long as you're left child, you don't care. As long as you're left child, you don't care. So you're the left endpoint. You keep going up and include the subtree when you're the right child. You don't care about the subtree at all. Okay. Okay. That makes sense. Ah, okay. You're taking it in the R, okay. 1741F. 1741F. Multicolored segments. Okay. And so we wanted to find the best in the return value. Okay, yeah, I've already edited the problem. I'll be right back. then increasing order of that. Hmm. For a particular index, which one is close? Well, it has to be the one that is not to the right. But how do you know? Forces around through. Right. So this one, going through them, you need to find for each segment a segment that starts not to the right of the current one. Was you need to find for each a segment that starts not to the right of the current one. But how do you iterate over that? That doesn't, yeah, that doesn't make any sense. How do they do this? Oh, debug? Yeah. Actually, it's an amalgamation, but this is from... So it's in the output namespace. scrape it a bit. Completely superficial, though. That doesn't matter. Wait, I thought this was removed when you submit it, or by a debug flag? Maybe this is, maybe it is, maybe it isn't. But the thing about this debug thing is it prints, like, all of the different, it prints the variable name and then the rest of it. So that's nice. I mean, pretty much everybody at that level is some variety of child prodigy. Whatever. I wouldn't worry about it. It's more like, be glad that they're doing this stuff instead of, like, making nuclear weapons or whatever. No, this is Code Forces. Markov, here's the problem. And I've already, like, sort of given up, because I don't understand. I mean, yeah, I would call this a legitimate give up. Yeah, Markov, I almost never will. During the week, it's, because during the week, it's because, I do the stock market stuff. So I'm never gonna be streaming in the morning during weekdays. But, like, yeah. Morning streams, yeah, on the weekend I may or may not do it. Nukes require a different kind of genius. Maybe, maybe not. Really don't know. Sort by each. Plus spec. Holy crap. Okay. I'm gonna, What solution am I going to look at? Maybe, I'll look at a top competitor solution. No, I do that I do algorithm questions every day to stave off existential dread. That's the reason. That's probably the real reason, I don't know. I don't really care. I just do this, and then when I'm done with it, I'm done. This guy got it KMJP got it very quickly. I didn't really forget him per se. I don't think so anyway. But that's fine. That's the way it's meant to be. Sometimes I forget, sometimes I don't. Most of the time I don't, though. Yeah, I can't quite get this. This was a bit too difficult. I'll leave it for later. We'll drop down to 1900. We'll see. See if there's an interesting problem here. Seventeen, 18, A2. To determine strength Vanth ruler, the inhabitants of the country gave them an array of exactly, how much time, how many steps? Select two indices L and R. Oh, let me change that. Select two indices L and R. Switch the one and a non-negative integer x. And then non-negative integer. Bitwise XOR. Okay. Round it up to nearest integer. L equals 1, R equals 4, and X equals 5, so it will fill the array with zeros in 2 seconds. You have 1, 3, 2. Actually, no, 1, 3, 2 is a good example. So you layer this with 1, and then you layer this with 2. I'll spend 2 seconds. So the n will not exceed 10 to the 5th. Guaranteed that the sum of n in all the tests does not exceed 10 to the 5th. First line has a single integer n, and is between 1 and 10 to the 5th. Second line, 0 through 2 to the 30th. It's guaranteed that the sum... So you have 01, 11, 10. Then you do this. Why does it matter that it's ceiling divided by 2? So it costs you the same amount of time to do, like, a segment of R minus L plus 1, total number of them over 2, and ceiling. So doing an odd number will, well, increase it. Okay. Whatever. 0, 0, okay, 0 required. Okay, 2, 5, 7, 2, 5, 7. Yeah. Oh, but it has to be L through R, right? It has to be consecutive. So you XOR these with 2. And now you get 0, 1, and then you XOR this with 7. With 2 and a 7. Zero 3 AI to the 30th. Minimum time that they'll need. Oh, this is tricky. Harry, thank you for the follow. 1, 2, 3, 3, 2, 1. Okay, so that's 1, 1, 0, 1, 1, 1, 1, 1, 0. 1. So you could do this whole thing. This becomes 1, this becomes 1, and then you can do this whole thing. Oh, no. That's not quite correct. You do this, then you do this. With 3, and then 1, 1. Well, so don't you just greedily, like, don't you just take whatever will zero out the leftmost item, and then extend it as far as you want? And then you just repeatedly do that. Okay, 10 to the 5th. Size of the array. Brute force approach, XORing every number. Yeah. Pseudo, please, yeah. The brute force is going to be that. And, well, I mean, that's to find an answer, but you need the minimum. You need the minimum possible answer. So the actual brute force is maybe maybe trying every possible combination, or trying every possible number of seconds. I don't know. But they're potentially 10 to the 5th different numbers, and tags suggest greedy. Except I don't really know. Don't really know where it would come from. And number 2, one of them for the entire array. No, minimum time would be 0. For example, like in this way, if all the elements are 0. But if all elements were non-zero, then yeah, sure, that would be that. And then round up on odd length. Two to 4. One. But how do you figure that out? costs just 4. Always cheaper to X. Is it always, and flipping 2 smaller ones? To XOR a long sequence of smaller ones that add up to the same length. Well, it's sure. Yeah, if you can get away with that. Because ceiling of r minus 1, ceiling r minus 1 plus L over 2. So odd rounds up. Yeah, odd length rounds up. R minus L plus 1 is the length of the segment. So odd lengths round up. Otherwise, it's just that over 2. So if one of the 2 smaller sequences is odd length, exactly one of them, right? Well, actually, if at least one of the 2 sequences, smaller sequences, is odd length, then you end up using more time with by chopping it up. Where the kth bit is said, every bit position, you know the start and end of all consecutive subsequences. Right, that's kind of the idea here, right? You have this, and then you have this. But it's like it has to lead to the answer this, and then this, and then this. Right, so it's kind of like you have to overlap here. But I don't know how to translate that to an actual algorithm. Like, I have no idea. Well, if fall numbers are 0 and 1, that's a reasonable like start, right? Fine. And then you have to like clear out the current index, and then see how far you have to clean it out. So you either just do itself, or you do 1 and then some consecutive zeros. Okay, suppose you clear that out. And over here you could either have 0 or 1. If you make it a 1, then it's kind of like you have a segment here. Otherwise you just have a single segment. Half the range rounded up, yep. Cost 2. Yeah. That's kind of what I'm struggling with as well, like when to do that. Yeah, this is one of the examples, right? This is the 1, 2, 3, 3. Well, I have it written up here. This one. This is example number 5. The other thing is, like, if it overlaps with something like this, you have to line it up with, I don't know. Yeah, no problem, Turtle. If you have any, like, lead code requests or anything, feel free to, like, let me know. I could probably do those on stream. Look for it, the range is odd or even. I don't know if that's a key per se. It's like, if you look at the first index, it has a problem. That problem is the 1 in the 2 to the 0 digit. And what is it going to cost to get rid of that problem? Well, it'll cost you a range of 1, or you could extend that to the range of 2, and then get 1 1 1 1 1 1 0 1 1 0. Or you could exchange it, send it to the range of 3 and get 1 1 0 1 1 1 0 1 1 0, etc. Like, and then would it be cheaper to flip the whole array and then flip the double O again? Half the range rounded up, that's 2, 2. That's 4. No. Because it costs you 4 to flip the entire thing, and it costs you 4 total to flip the 2 sets of 1s. And then flipping the 2 in the middle would cost you 1 again. Yeah, so that won't work. But how do you know how far you want to go? Just take each group of what by itself? Oh, you mean the ones and the zeros and the ones. Yeah, but if you combine them to a single XOR operation. Sure. You get these two. Oh. That's the music. One zero zero one, and then just clear these out. Yeah, no problem. 0110. Yeah, pseudo. This one's like it's 1900 on Code Forces, so it's relatively difficult. It's roughly at the edge of my ability, probably. I just have to think about this one some more. Yeah, so this is harder than most lead code problems. Yeah, that's for sure. Normally, thank you for the follow. Okay, 1001.